Okay, welcome everyone to trigonometry. My name is Mr. Naylor. You're going to discover that trigonometry is a really exciting class that connects geometry with algebra. But we've got a lot to do to get to that point. In fact, the first thing I do for our first few lessons is really more of some introductory topics. All are necessary for us to understand trigonometry, but I just want to let you know that I guess you could say we're not officially starting the trigonometry until we get past some of these introductory ideas. So there could be some of these ideas that you feel like, yeah, I know that. And there might be a couple things that are said that you might say, yeah, I don't know that. So it's a great place to start. And as you can see, we're going to start with topic 1.1, angles. Now, you should know some things about angles, but I want to give you some angle terminology that will basically get us all on the same page. Now, when we talk about an angle, we'll say that an angle has an initial side. The initial side is going to be the fixed starting red. It's going to be the part of the angle that basically doesn't move. That's why we say it's fixed. But the terminal side, now the terminal side is going to be the rotating, or as sometimes we'll say, the ending part of the angle, so the ending ray. Let's draw it, okay? I think you'll find out that what I'm about to draw for you here is not a big surprise, but if we have an angle that may be on the X and Y axis, now this might be a little bit of a new idea, drawing an angle on the X and Y axis, but let's say we have an angle like that. And the angle, of course, is made up of two sides or two rays. Well, one of these rays is the initial side. And that will be the one that is on the x-axis. And then since we rotated to this ray, that would make this one the terminal side. That's all when we talk about the two sides of an angle. Now, the interesting thing about the way that I drew that angle is that it is in standard position. Now, standard position is the way we will always draw all of our angles. And that is when the initial side, is along the positive x-axis. So standard form is the way that I drew my angle because the initial side is along the positive x-axis. That's always where we're going to start our angles that we discuss. Now, I guess you could say a few more kind of introductory ideas that go along with this topic. One of them I'm going to put under a pretty generic heading here. We're going to call it direction. Maybe you don't realize it. That's why we're here, so that we can make this part of our knowledge that when you start rotating, you can rotate in different directions. Now, if I rotate in that direction, which happened to be counterclockwise, if I rotate in that direction, that's a positive rotation. Now, be careful, because right here, sometimes students start making mistakes. They say, oh, yeah, because it's in a positive place. No, I could rotate in this direction, and I could end up in many different places. So I don't want you to think about the place. I want you to think about the direction that we went. That's a positive rotation. And as I said, that's counterclockwise, although I don't use that terminology too much. You can have a negative rotation. You can have negative direction. Negative direction is not because I'm in a negative place. It's just because I went that way. By the way, that way would be clockwise. But I don't like to use those terms, clockwise and counterclockwise. I more just want you to say that if you go this way, that it's a negative rotation. Now, when we talk about rotations, there are some rotations that should be pretty familiar to us. Okay, they should be pretty familiar. But we're going to make sure that if I say 0 degrees or 90 degrees or 180 degrees, or 270 or 360, that we're all pretty comfortable recognizing those four corners. If I say 45 degrees or 135 degrees, what would these be down here? Now, as you can see, I'm certainly just going in increments of 45. So just add 45 to 180, right? That would be 225. And just add 45 to 270, and that would be 315. So we should be pretty familiar with those numbers. I want you to be able to locate those. I want you to be able to recall those pretty easily. Just one more thing with rotation. We'll just call it some more rotation. And maybe of all the things that I've said here so far, this might be the one that kind of catch your attention and you might say, oh, I didn't know that. So watch carefully. Now, this is one that you want to watch because look what happens when I rotate this far. Yes, I did want to rotate that far. Well, I'm at a certain angle. It would be an angle that's greater than 360. And let's say that I went exactly 45 more degrees so that I can stand here and say to you that that would be 405 degrees. Well, there's such a thing as a 405 degree angle. It simply means that I rotated beyond one revolution. What about this negative rotation thing? What if I rotate like to here? What if I rotate that way to there? Now, I didn't put this on the board yet, but it wouldn't be hard to create the negative rotations because this then would be considered negative 90. This then would be considered negative 180. And this one would be negative 270. And I'm just trying to imply that I'm somewhere between those two negatives. Let's say that I'm exactly halfway between so that we can write negative 225. All I'm trying to show you is that there is such an angle. And that would be an example of a negative 225 degree angle. Now, I have purposely shown you just enough so that you can ponder this little question. I want you to create or identify two different angles that would have the same terminal side. Now, this is an interesting question for the first day of class. I haven't shown you this, but I've given you enough knowledge to be able to try to find two different angles, yet they have the same terminal side. Now, if you're saying, okay, Ms. Naylor, what do you want me to do right now? Well, I want you to try this. So that might mean that you're sketching something. It might mean that you're writing down some numbers. It actually might mean that you're doing a little bit of both. So try it. And if you're watching this on the video, this is the time where you need to pause the video so that you also can think about this. If you're just going to play the video and wait for the answer, you're going to miss out on the thinking. How could you create two different angles? They're different, but they have the same terminal side. Now, if there were students in class at this time, I would take some volunteers. And one of the most common responses is that there'll be someone that noticed that this angle I drew, this 405 degree angle, could also be described with the same terminal side It could also be described, I'm sorry, I shouldn't really say it could also be described, but an example of this would be a 405 and then a 45, okay? Because the 45 would have the same terminal side, but it would be a different angle. Now, what I'm trying to show here is that the 45 degree angle is clearly different. It's smaller, yet it stops at the same place. And so it has the same terminal side. Now, that's a little bit of kind of a hint, because if you can just get your angles to stop at the same place, then you would have found an answer to this question. Do you see another one that we could do? Well, maybe you see the one that I drew here, because it definitely is true that if I go to negative 225, that would also mean that I could go to 135. And those two angles stop at the same place. They stop at the same terminal side. Does anybody else have an example? Sometimes I'll have somebody give the example of 180 and negative 180. Now, there's something true about all these angles. They're different. They're different because they're different numbers. They're different because they're different sizes. But there's something that's the same. And that is correct. They stop at the same place, so they have the same terminal side. And what we've just created here is a special kind of angle in trigonometry. They're called coterminal angles. Now, coterminal angles are two different angles. We can put the word different up here. They're two different angles. They're always going to be in standard position. We always draw the angle starting on the positive x-axis. But they're two different angles with the same terminal side. And we call those coterminal angles. Now, by the way, what I just did with you here is a real simple example of a strategy I like to use in the classroom called synthesis, where we had some different ideas and we put them together to understand the new idea. And so I gave you a couple different ideas. The idea was that we can rotate in different ways. The idea was that we have this thing called a terminal side. And now I had you put it together. And when those are the same, when you have the same terminal side, we have coterminal angles. A common question would be to find a positive and negative. Find a positive and negative coterminal angle. And I would have to, of course, give you I'd have to give you the original angle. And so let's use the one that I came up with here, 155. So find a positive and negative coterminal angle for 155. Now, how's that going for you? Some of you are drawing a sketch right now. Okay. But some of you may have noticed that there's something true about the numbers in each of these examples. Okay, it's actually quite simple. Something's true about the numbers in these examples. That is correct. They are all 360 degrees apart. So in effect, we could say if you have 45, all you got to do is add 360, and now you have 405. You could also go the other way. You could say you have 135 and you could subtract 360. And if you subtract 360, you get negative 225. And so we come up with a real simple way to find any coterminal angle. All we have to do is add and subtract 360. Now take a look at this definition. It's a little bit fancier. First of all, we have a variable in here that stands for an angle. We call it theta. Okay, it's not the Pepsi sign. Now that's theta. It's a Greek letter, and we would say that that would be like the angle or the degree measure. So if we have theta, then all angles of the form theta plus or minus 360K. Theta plus or minus 360K, what is this? Well, essentially it's saying that I could take my angle and I could add 360 or subtract 360. And the letter K is just saying that we could do that as many times as we want. In other words, I could have two 360s. Like I could add 2 extra revolutions. Okay, and whenever you do that, you're going to end up with a coterminal angle. Okay, so how's that going over here for our example? Okay, it becomes a pretty simple problem. All we got to do is add and subtract 360. And if you add 360, of course, you come up with 515. And if you subtract 360, well, you're going to come up with negative 205. So what's the deal with these numbers? Okay, yes, they're coterminal, but do we understand that they are going to have the same terminal side? Okay, this is the part that you're going to start to understand. I know it's only day one, but you're going to understand more that if I ask you to sketch 155, well, that would be pretty easy. But that would be the same position as asking you to sketch negative 205. Now, notice I said it would be the same position, but it's not the same angle, okay? It's not the same angle because the direction that I went and also because of the size. How about this 515 angle? Okay, now this one requires you to kind of spin around a little bit, but 515 would just be an extra revolution. So I spin around and then I stop at that same terminal side and we end up at 515. If you're wondering why do we need the different angles to describe the same position, just hang on. Okay, that's where we're going to be going soon enough. All right, coterminal angles. Just summarize that for a moment in your mind. What is coterminal? That's right, 2 angles that stop at the same place, right? 2 angles that are 360 degrees apart. And sometimes students will tell me that they're the same angles. Remember, they're not the same. They just stop at the same place. Now, the other thing I like to do today is talk to you about something called a reference angle. And by the way, I'm teaching this a little differently. This time now I'm giving you the definition. And so we're going to do a little analysis. In other words, we're going to read the definition, and then we're going to try to understand what's a reference angle. Copy the definition down. As you write it down, think about some of the key words. Now, just so we're not getting overwhelmed here, this is theta prime. A lot of times the prime symbol is used to describe an answer that's connected to the original answer. So the original angle is probably theta, but theta prime is connected to it. It's the reference angle. So what's a reference angle? Well, first off, it's an acute angle. Now, if we stop right there, an acute angle, remember from geometry, is an angle that is less than 90, but greater than 0. So an acute angle is an angle that's between 0 and 90. That's really important for this lesson or for this conversation on reference angles. What else do we have here? The reference angle is formed by the terminal side. Okay, I know what the terminal side is. It's just the ending side. It's the rotating side and the x-axis. There's kind of a reason that that's highlighted. All right. Well, a lot of things in math, you say, show me, right? So I'm going to show you an example for a reference angle. If we're given theta equals 32 degrees. Well, this is pretty common to use this structure where we say given theta equals 32, and then we could say we would want to find theta prime. And let's change the color because I'm going to end up doing this in yellow. Okay, well, you're going to find out more than a few times this year that a sketch can be helpful. So if you don't know what to do, draw something. And I hope that we can draw a 32-degree angle. We all know that it would be essentially right there. All right, so I'm looking for an acute angle. Oh, well, 32 degrees is already acute. All right, you seem to have that taken care of. Terminal side. Well, this is the terminal side. Okay, I don't need to look real far. I don't need to make something up. That's the terminal side. Where's the x-axis? Where's the x-axis? That's right, the x-axis is right here. What that means is that I want to think about this angle that is formed with the terminal side and the x-axis. Well, I don't have to think too hard because I think that that angle is 32 degrees. Yes, the reference angle is the same as the original angle. All right, now that's for that situation. I'll fill you in a little secret here. We're actually going to go through 4 situations, which in the end, I think you'll see how each one fits this definition. How about theta equals 125? Theta equals 125, find theta prime. As I said before, make a sketch, okay? Because especially if you don't know what's going on here, you do know what 125 looks like. Okay, acute angle. Okay, well, I know 125 is not acute, so we got to keep looking. Terminal side. Okay, I know what the terminal side is. We just got done talking about that. And so that's the part that rotated. There's your terminal side. X-axis. Okay, well, look carefully because now the x-axis should be thought of in this location, because what is true about this angle? What is true about this space? That's right, it fits this definition. You see, this angle here, this space right here, is the acute part that goes to the x-axis. All we got to do is figure out how big it is. See what you can do with 180 and 125? That is correct. All you have to do is subtract them. Now, if you subtract 180 with 125, you get 55. Now, folks, 55 degrees would be the reference angle. It would be acute. It's with the terminal side and the x-axis. And so, again, we have another winner. Let's look at, I'm going to go ahead and squeeze it down here. Maybe not a great idea, but I'm going to do it. Let's look at 210. Now, if theta equals 210, how about theta prime? Okay, now at this point, students may feel like that they are ready to journey and do this on their own, which I'm going to encourage you to do. I would be encouraging you right now to sketch 210 on your own. You should be able to sketch 210. I would be encouraging you to start to think about the definition. Okay, now when I say think about the definition, I mean sort of piece by piece. Acute. Okay, obviously 210 is not acute, so we got to keep looking. Terminal side. I hope you're getting pretty good with that. Okay, because the terminal side is always the side that was the one that rotated. All right, and then it's time to think about the x-axis and the space between it. Now, if we were in class, if there were students in class, a common mistake would be to refer to that pink space, that pink angle. Why is that a mistake? Why is it a mistake to think about that pink part. That's right. It's not with the x-axis. It's actually with the y-axis. Now, that is a really common mistake because that seems like the empty space. That seems like the space that you want to fill. But nobody said I'm trying to fill a space. It just says I'm trying to think about the x-axis and the terminal side. Now, your brain, your eyes, you need to start to just see this angle, because this angle right here in yellow is the one that is going to fit the definition. And once again, all we have to do is subtract with 180. Okay, now if you're careful, you would say that you're actually subtracting the other way, because now you're subtracting the original angle theta minus 180. But you're still finding the difference, right? You're still finding the difference. And the difference between the x-axis and that terminal side, 30 degrees, is your reference angle. Okay, be careful, not the quote-unquote empty space. Now, maybe you're saying, is it always this way? Well, I would say to you, what do you mean this way? Because in the first problem, we just used the angle. In the second problem, I subtracted x-axis minus the angle. In the third problem, I subtracted the angle minus the x-axis. So, is it always this way? The answer is yes. Can you make it work for this last theta? Find theta prime if theta equals 315. If theta equals 315. Okay, a little sketch. 315. And soon this will become pretty natural for you. All you got to do is think about the terminal side. Oops, getting a little messy there. The terminal side and the x-axis. Okay, now, what is the difference between 315 and the x-axis? Well, if you think of the x-axis as 360, it's easy to see that that difference is 45 degrees. So what we want to notice now is that we did subtract with different numbers. Working backwards for this problem, it required me to subtract with the full 360 x-axis. For these two problems, I had to subtract with just the 180 x-axis. And you might argue for this one, I didn't subtract at all, unless you want to say you subtracted with the 0 degree x-axis. And these are our 4 situations because there are 4 quadrants. Okay, this one is quadrant 1. This one is quadrant 2. This one was quadrant 3. And this one was quadrant 4. So depending on which quadrant I'm in is going to require me to subtract with the x-axis. Now, I'll be honest, I'm not big on rules. I'm big on you understanding how to come up with these rules. And most students, they will make a sketch and they will just think, how do I have to subtract? But you're going to find yourself always subtracting in this manner. So it's not bad to notice that so that you can apply it for the next problem. Okay, which is exactly what I want you to do. For our closing problems here, you want to try to work this out for 267. And then as time permits, I wonder if you could work this out for negative 230. I don't want that to be in yellow, but I do want to put a star beside it. Go ahead, see if you can find theta prime. See if you can find the reference angle. Okay, now 267 is all the way over here. But the real question is, how much beyond 180? How much beyond 180 is 267? Okay, so we have ourselves a subtraction problem where you can take 267 minus 180. That'll get you what? 87? Okay, so 87 is the size of this space. Now, I got myself a little bit flustered here. I wanted this to be negative 230. So if you haven't had a chance, why don't you think about how to do negative 230? And I apologize for not having that correct the first time. Yeah, how are you going to do a negative angle? How are you going to do a negative angle? Well, I hope that you're going to say the same way. The same way. You're going to sketch it. Now, if you sketch negative 230, you have to have a little bit of knowledge that it's past negative 180, but it's not going to be it's not going to be the whole way up to the next one, which is negative 270. So we have negative 230, and we have the reference being negative 180, that is the x-axis. Now I'll have students start to say, well, what do I do with the negative? Do I ignore them? I might say loosely, yeah, if you understand that you're just finding the difference between those numbers, the difference between these numbers has to come out to be positive. So if I kind of ignore the negative, I could still very easily say, well, that distance, that difference is 50 degrees. I could do it with the negatives. I just have to be really careful, because if I do it with the negatives, it's negative 180 minus negative 230. And that, of course, by rules of double negatives, is also going to come out. It's also going to come out to be 50. Okay. Now, this problem, it starts to deviate a little bit from these rules, doesn't it? Because these rules really only apply if theta is positive. But as you can see, we still subtracted with the x-axis. We just thought about the x-axis. If we wanted to, we could think about it as negative. Or if you wanted to, you could think of both these numbers kind of in their absolute sense. You could kind of ignore the negative, just find the difference, and you get 50. All right, now this would officially end this first introductory topic. And there's a homework helper 1.1, that goes along with this lesson.